This is Helen from Helen Westwood Maths. I just thought I'd quickly jump on this morning. I've had a request to do a quick video just with some helpful hints and examples for how to work with Pythagoras. So with Pythagoras theorem, the first thing it's really important to remember is that this always applies when we have right angled triangles. And the first thing, just to check that you're happy with, is that you can identify the hypotenuse on a right angled triangle. Now, we often talk about the hypotenuse being the longest side of the right angled triangle, and that's absolutely right. But a safer way of thinking about it is that the hypotenuse is the side opposite the right angle. So if you locate the right angle on the right angled triangle, your hypotenuse is always the side opposite to it. Now that becomes important when we're going to be using Pythagoras theorem to work out sides of some triangles. So basically what Pythagoras discovered was that there's a link between the squares drawn on the sides of triangles and the side lengths of those triangles. So this is sometimes taught with a formula. It often appears in one of two forms, either a squared plus b squared equals c squared, or a squared plus b squared equals h squared, where h or c is the hypotenuse or the longest side. Okay, so how we work this out, it doesn't matter which of the two other sides we call a and we call b. Okay, so the way that we'd work out in an example number 1 is if we're going to say that a is 3 and b is 4, 3 squared plus 4 squared is going to be equal to our hypotenuse squared, which you can see is labelled with an x. So the first thing we do is square those two numbers. So that gives us 9 plus 16 is equal to x squared. So we get an answer of 25. So 25, bear in mind that is x squared. It's not the answer to x. So the way in which we work out the length x is we're going to do the square root of 25, which tells us our value of x, our hypotenuse length, is 5 centimetres. Okay, so doing triangle number 2 next. So again, you can see where the x is for the hypotenuse because it's the side opposite the right angle. So a equals 5 and b equals 12. So I'm going to use again the a squared plus b squared equals hypotenuse squared. So we'd substitute in the values that we've got. A is 5 and b is 12. 5 squared is 25. 12 squared is 144. And that is equal to the hypotenuse squared. And then we add those two together, we get 169. Bear in mind again, 169 isn't the length of that hypotenuse, that's the hypotenuse squared. Imagine if we drew a square on that side. So the way in which we work out what h is we work out the square root of 169. What number times by itself gives us 169? And that is 13. So x would be 13 centimetres. Now, Pythagoras is only used for finding sides, finding side lengths, or proving that a triangle is right angled. Now, if we look at this last example, you can see this time we're not working out the length of the hypotenuse. Whereas this time we've been given the length of the hypotenuse, we're finding one of the other sides. Now, we can still use our same formula. A squared plus b squared is equal to the hypotenuse squared. If we call the side label of the x a, when I substitute that in, we're going to write x squared plus 9 squared is equal to 11 squared. And then when we work out the value of those squared numbers, 9 squared is 81, 11 squared is 121. And then this time, in order to get we're trying to work out what x is, so we want to get that letter by itself. So we use our solving equations knowledge. We minus 81 off both sides. And that gives us that x squared is equal to 40. And then just like before, in order to work out what x is, we've got to work out the square root of 40. Now we can sometimes get an answer that's a decimal, so I'm going to round the answer that I get to 1 decimal place. So that would be 6.3 metres. And it's often worth just asking yourself, is my answer reasonable? The fact that comes out as 6.3 metres, it's less than 11 metres, it's shorter than the hypotenuse, which is what we're expecting, because we know that side of 11 metres needs to be the longest side. So you've got an example there of how to find the hypotenuse, example how to find one of the shorter sides. Notice we do the subtracting rather than the adding. And then just to finish off, some people, if they find it difficult to use the formulas, you can actually use this 3-step method to solve problems involving Pythagoras. So our first step is we square the numbers that we're given. If we're finding the hypotenuse, we add those numbers together like you saw in the first examples. If we're finding a shorter side, we subtract. And then finally, we work out the square root. Okay, happy solving Pythagoras problems, and I'll see you online soon.